We're now going to turn our attention to the fundamental theorem of algebra in chapter 2, and to properly state it, we need to build up the algebraic structures that we're going to be using. So what's a polynomial? Well, given a subfield k of c, a polynomial, we say either over k or with coefficients in k, is a formal expression of the form r0 plus r1t plus r2t squared. Oh shoot, I should say a polynomial over k in the indeterminate t is a formal expression of the form this, where the coefficient, these r's are in our subfield, and n is some positive integer. So that is what a polynomial with coefficients in k is. And it's understood that if a coefficient is 0, then we don't write it. Well, I should say we don't usually write it. And we will often just use notation to refer to a polynomial. So we may just say that r is this sum of coefficient times power of t is a polynomial in t. And then, of course, the coefficients are in k. So, you've dealt with polynomials your whole life. The only thing that's going on here is that we're restricting our coefficients to be in C, and we may even restrict them to be in a subfield of C, and we will do that. Let me say one last thing here. In the next video, we're going to deal with polynomial arithmetic, but we say that two polynomials are equal if and only if they have the same coefficients. So that is, the formal expressions that we write are exactly the same symbolically. Now, two polynomials can not appear to be the same, but they could be equal. Maybe one of them has some extra zeros added on. So it's understood that if the coefficient is not there, it's 0, and if it's 0, we don't need to write it. Okay, so just to be clear, that it could appear that polynomials, for example, have the same leading power, but they aren't actually equal. So, for example, a quick example before we do polynomial arithmetic is, we could have had the polynomial 2 plus 1/3 t squared plus 0t cubed, and then we could have the polynomial 2 plus no t's plus 1/3 t squared plus 0t to the fourth. Of course, these polynomials are equal, even though it doesn't appear they have the same coefficients. We just have chosen to write the zeros in one of them, well, in both of them, write some of the zeros and not write out the zeros. So we just have to be slightly careful when we're doing proofs to ensure, whenever we're dealing with the equality of polynomials and we're looking at the sort of the leading coefficient, which is something we will do.